Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to open a notepad file. Let me answer this question with practical demonstration. In Java programs or by using Java programs, if you want to open any software, okay, then we have to use a predefined class in Java known as process builder class, and for which you have to create an object. And then later you have to say, using the object reference, you have to say object reference dot start. This will launch that particular software, whatever you want. Okay. Here we have to give the path of the path of the software, whether it may be notepad. In this case, the question is all about notepad. We have to give the path of the notepad. Okay. Let me explain that. Further, I'll switch to Eclipse IDE and create a new class here, guys. I'll just name this class as class 5, some random name with main method I'll create. And in order to launch any software by writing some Java program here, with the help of this Java program, I want to launch any software. I have to create an object for the process builder class. Process builder PB is equal to new process builder. Okay. PB is equal to new process builder. Like this, we have to create an object for the process builder class. In the constructor, we have to pass the path of the notepad. If you want to launch notepad software, you have to find the path of the notepad software. Okay. How to find the notepad path of the notepad software? Okay, you can go to Google and find it out, guys. What is the just type here. What is the folder path of notepad file, exe file? Okay, exe file in Windows 11. Okay, Windows 11 machine. What is the exe file path of the notepad software? Okay, if you go there and you see, it is clearly saying that in the C Windows System 32, you'll find the notepad.exe file available. Okay, so to confirm that whether it is right or wrong, you just go to the C drive and go to the C where it is saying C, then go to the Windows folder, go to the Windows, and in the Windows, you go to the System 32 folder. Just type S here, you will find the System 32 folder. Then in the System 32 folder, you have to find the notepad. Just select N. Just keep going with the N, guys. Okay. Till you find the notepad software, you have to keep pressing the N here. Just keep pressing. N O should come. Here it is E. D. Okay. Is there any software that we found so far? Notepad, right? Okay, here N. Let me find in a proper way, guys. Let me fully go. You can otherwise you can search also. That's not a big deal. But let me find manually here instead of searching. So just press N and until you get that notepad. Just keep searching here. He is done. NOT should come. Natural is coming now. Yeah, here somewhere you see notepad.exe file is found. Now right click on this notepad.exe file, select properties, and you'll get the path here. Copy this path of the notepad.exe file and paste the path here. Okay, paste the path. And here double backward slash, you give the name of the file with the extension. Okay. Any software, guys, not only notepad software, any software, if you want to launch, you have to give the full path. Okay. Dot start you have to say. Dot start you have to say. Okay. So this is the code you have to write, guys, and there is a possibility of exception. If in case this particular notepad.exe file is not available at this particular path, there's a possibility that you cannot start method may not work. So over the mouse and you have to surround with try catch blocks. So surround with a try catch block here. What is that possible exception? They are saying input output exception. Okay, they're saying input output exception. So catch IO exception. Okay, IO exception you write down. Okay, IO exception, and here E. Just write down system.out.println E. And here you have to import this IO exception from java.io package. Okay, now run the code and see whether the notepad software is getting launched or not. This is the way to launch the notepad software, guys. You have to give the full path of the notepad software. Okay, you see notepad software has already been launched, guys. Here, as you can see, I'll run it again and show you because it was not able to focus on that. Right click, run as Java application. Let's focus on the notepad software is coming or not. You see notepad software is automatically getting launched. Okay, this is how we have to write the Java code to launch the notepad software. Not only notepad software, guys, if you're interested in launching launching any other software, Again, you can use the same code, and in place of the notepad.exe file, provide the path of that. For example, if I want to launch Chrome browser, if I want to launch the Chrome browser, what is the folder path of the Chrome browser? Okay, so I can easily find out here. I'll go to see this program files, C drive. In that C drive program files, in that Google is a folder. If you want to launch any other browsers like Mozilla Firefox browser, if you want to launch, you have to go inside this folder. If you want to launch the Google folder, okay, do one thing, just go to Google folder. Google Chrome means in that Chrome folder you go, in that application you go, there you will find chrome.exe file. Take the full path of the chrome.exe file, select there is that select, right click on this and select properties option and take the full path. And here give the path, guys, give the path. And okay, in that you write down chrome.exe file, chrome.exe file. In that write down chrome.exe file. Okay, or you can directly copy from here chrome.exe if you don't want to do any mistake. Okay, just give chrome.exe file. This is the way, guys, this is the way, nothing much. Okay, so run the code here, guys, run the code and observe that Chrome browser will launch. Okay, this program will launch the Chrome browser. You see Chrome browser has been launched. Okay, Chrome browser will launch. Like that, any full path you give here, guys, and run the script, it will launch the required stuff. Okay, it will launch the required stuff. So hope, guys, with a practical demonstration, you have understood how to launch a Notepad software or any other software in your machine using the Java programs. If you want to launch, this is a way to launch, guys. Okay, this is a way to launch. This is a way to launch the required software in your machine using the Java programs, using the process builder predefined class. By calling that start method, we can start it. Okay, we can launch the required software in the Java programs. So hope, guys, with practical demonstration, you have understood how to write a Java program to not only open a notepad, but open any other software in your computer machine. So this is a code for that. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to demonstrate linear search. Let me answer this question with practical demonstration. Before we move to the practical demonstration, first you need to understand what is meant by linear search. There are different type of algorithms we have in Java: linear search, binary search, hash search, like that. Linear search is one of them and is the simplest one. Very simple, guys. Okay, so linear search is also known as sequential search. Okay, it's also known as sequential search. Let's assume that. Okay, I'll give one real-time example. Okay, so there are 10 people here, guys. Okay, there are 10 people. Okay, there are 10 people. Let's say in a police station. Let's assume that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people are there. Okay, so some robbery happened at your house. Okay, some thief has, okay, stole some items from your house. Some thief has come to your house and stolen, and at that time you you try to catch the thief, but unfortunately thief has got left your house. You are unable to catch him or something. Okay, then as you are a person, right, you have remember his face. Okay, thief's face you remember. Okay, so now you went to the police station to complain, and after a few days police people have called you that they have these 10 people, okay, they brought, and you have to identify them. So in case of sequential search, what you will do, you will start with the first person. Okay, is the face that you have seen of the thief is matching with this person or not? No. Fine, then you'll go and go to the next one in the line. Okay, you'll not this very simple algorithm, guys. One by one you'll check and rule out. Sometime what happens is, okay, maybe this person is a thief. Let's say it got identified, face got matched. Like this, you will find the item. Okay, searching, you are searching for the thief in this particular 10 number of thieves. Okay, 10 number of people who are suspects. Okay, so in this 10 suspects, who is the thief? You have to find it out. So for that, since you identified the face of the thieves, you have to go here to the police station when they call, and you have to go and see the face of each and every thief in a sequential order until you find the thief's face who has really stolen from your house. Okay, this is what is sequential search or linear search, guys. But what if if you have to apply this sequential search in a different situation, you went to a cricket stadium. Let's assume that you went to a cricket stadium. So there, in the cricket stadium, a lot of people are there. Okay, thousands of people are there, guys. Thousands of people are there. Okay, the people are like anything, and in this people, one of the person is a thief. Let's assume that one of the person is a thief. That particular thief has stolen your purse. Okay, now tell me, can you do if you follow this linear search algorithm where you have to you just remember the face of the thief. Okay, you start from here. Okay, the face is not matching. Then you will go here. Is it suitable? Is a linear search algorithm suitable here to find the thief when there are more people at the stadium? If there are only 10 people in the police station, you are able to find it by applying the linear search one by one. You are going here. For this, you will not go with the linear search algorithm, guys. You will be rushing. You see, in this case, right, you will not be checking one by one face. You will directly move like this. Okay, directly move like this or like this. You will try to cover this number of people in a faster way so that you can catch the thief fastly. But you cannot go one by one. That will not work. It will take a lot of time. Okay, there will be a lot of time. By the time the thief will escape, the thief will escape also. Okay, so you see, linear search algorithm for finding the required element in the list of items, okay, is less, then we can simply use a linear search or sequential search, the alternative name you can use for searching the particular item from the collection. If not, okay, if the items are very big, the linear search algorithm will take a lot of time, guys. Then it is not suitable for finding the required item from the list of items, okay, collection of items. Okay, if the list is very big, then you will not be able to use linear search in that case. Okay, linear search, also known as sequential search, simple searching algorithm that checks each element in collection. Collection can be an array list, anything, one by one, until the target element is found or the entire collection has been searched. Okay, you have to either find the person or find the element, or you have to complete searching for all the things in the collection. Okay, it's slow compared to the other searching mechanisms. Okay, it's slow when compared to the other searching mechanism. It's kind of very slow, guys. It's kind of slow compared to the other searching mechanisms. Okay, so and it is only recommended to use. Okay, if you are using this sequential linear simple searching mechanism algorithm with a large list of items, right, it will be slow, and you'll get the results very late. Okay, so it's better you generally go with the linear search when the list of items in the collection, that is array or array list or any other, okay, as said, hash map, anything, when you're searching in that collection, right? Okay, if the collection items are less in number, then you can go with the linear search. This is a theoretical part, guys. Okay, slow compared to other searching mechanisms and suitable for the less number of elements available in the collection, means you generally apply this linear search for finding the required element in the list. Okay, so it can be an array, a collection or list. Here is an array, list, or collection, whatever it may be, you can call. Okay, so I'll demonstrate with this different examples. I'll use arrays here. Okay, and we'll do that searching operation. Okay, so for that I'll switch to this Eclipse ID and create a new class, guys. I'll just create a new class. In this Eclipse ID, I'm going to create a new class. I'll just name this class as let's say class 6. I'll just name this class as class 6. Class 6. With main method, I'll create finish. Now inside the main method, I'm going to write the code. Inside the main method, I'm going to write the code. That is, what is the code? Okay, so I'll create an array list, guys. Okay, you can create anything, guys. It can be an array. You can create an array or array list, whatever it is. From collections, you can create array list, or from you can create an integer array. Anything is fine. Shortcut representation of the array I'll create. Let's say 9, 5, 1, 7, 8, 2, 3, 6, 4, 4. Let's say these are some elements I have given. Okay. Now in this array, I have to search. Okay. I have to search for a particular element. Okay. So what I will do is, for int I is equal to 0, I less than the size of the array, ar dot length, semicolon, I plus plus. I'll iterate through all the elements in the array, guys. That's what and what is the target element? For example, 1 minute. For example, what is the target element? Int target is equal to, let's say, some 8. 8 is the target, let's say. Okay, 8 is the target element. Okay, I have to search for this particular target in this array. How the searching will happen? 8 will be compared with 9, equal or not? No. Then 8 will be compared with the next element, 8 equal to 5, no. 8 should be compared with 1, no, not matching. 8 compared with 7, not matching. Then 8 compared with 8, matching. So the iteration will end, and you'll get that something. Okay, so here what I will do here is I'll write the logic for the same, guys. I'll compare this. I'll try to implement this linear search or sequential search, which is simple searching algorithm, right? To implement that linear search, right? Okay, to implement this linear search, I'll write the logic here. Okay, this is the logic for the linear search. Very simple one, guys. If AR of I in this array of index I, if that is 0, AR of 0 means 9, is double equal to target, then what is the thing, guys? Then return the index of the I. Okay, then return the index of the I and break the for loop. If not, here return, after all this for loop iteration is done, still this returning is not done, then return -1, guys. Okay, return -1, and the return type should be here. This is a main method, guys. Let's take this logic to other method, guys. It will be better. Public static void linear search linear search demo. Here I'll pass this array, guys. Okay, as a parameter I'll pass this array, integer array or ARR, I'll say, comma target. What is the target that you have to search for in target? Okay, these two things we have to provide to this as a parameters. Okay, we have to pass them as arguments to this particular parameters, and you don't have to, here you need to call that, guys. Okay, here you don't have to give the for loop and all. Just put all this code inside the this method, reusable method, where replace this AR with ARR and replace this target. I'll say T here, T for target. Okay, ARR of I, return I, break -1. Just will come to that. Okay, here I created the array, here I created the target. Now I need to simply call this method, guys. Linear search demo method I need to call. I'll call this method here, and as a arguments I need to pass this. What is first argument? I have to pass the array. And second thing that I have to pass is the target. When I pass that, this particular method should have the return type, because return I means, what is the type here? I is for int type. So return type is int. If the element is found, okay, here you don't have to write the break statement, because return will actually terminate the program there itself whenever it is occurred. When return I means, it will come out of the for loop, not only for loop, but also from the method it will come out. So it's no need to write the break statement here. Return -1. Okay, either return index, if the element is found, this particular method when called will return the index of the element, or it will return -1 if the element is not found in the searching operation. Okay, now run the code and see. When I run the code, okay, so this particular method calling statement is getting this int as return type over the mouse, and here int is coming, int r for result, or int result, otherwise int result. Okay, here I'll write the logic. If result is not equal to -1, if the result is not equal to -1, then write down system.out.println target plus element is found in the target element is found. Okay, found at the index, which index it is found? At the index. Target element is found at the index. This result is nothing but the index here. Okay, result. Else what you will write? Else you don't have to write the curly braces. Only one statement is that curly braces are optional, guys. You can, if you want to write, you can write it also, but they are optional here. Okay, they're optional. If only one statement is there, is no need of providing the curly braces. So I'm not writing, but let me go like this for now. System.out.println. Here I'll say target plus element is not found. Okay, -1 means not found. No need of printing any index. If it is -1 means why to print the -1 there. Okay, so this is the program, guys. Let's run this code and see. I'll improvise the program a bit more, but for now we'll go with this. 8 element is found at the target element. 8 is found at the index 4. Find it out. 0, 1, 2, 3, 4. Yes, at the fourth index 8 is there. What if I give something like 12 here? 12. Is 12 there in this particular arrays? Element in the array elements 12 is there? No. When I run the code, what will happen? 12 is not there, so minus 1 will be returned by this method, linear search algorithm method, and minus 1 not equal to minus 1 will become false, else block 12 element is not found will come. Okay, instead of hard coding or manually providing the element value here, what I will try to do here is I'll just write down. Okay, here I'll write down something like this. Okay, that is, I'll write down something like this. That is here, I would like to collect this input from the target element from the user. Scanner is equal to next new scanner. Scanner is equal to new scanner. Here I will say system.in. Simply write down Control Shift O. Control Shift O. Scanner will be imported from java.util package. And here I need to help the user in entering the target. Enter any number that you want to search. Okay, enter any number that you want to search. Here int target is equal to scanner object reference dot next int I will say. Okay, using this next int I'll intake, and here I'm searching. Fine, run this code. And here scanner object, once the input is collected, right, it's a good practice to close the scanner object. Instead of giving the task to the garbage collection mechanism, you yourself are closing this object so that memory leak won't happen as part of the best practice. So right click run as Java application. Let's observe that what will happen. It will ask the user to enter any number. If the user enters any number, say 9, 9 is found at the index 0. Yes, 9 is there with the 0th index only of this array. Now run this. Let's give something like, 7. 7 element is found at the index 3. 0, 1, 2, 3. Now let's give another number. Let's give the number like 4. 4 element is found at the index 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. At the 8th index, 4th element is there. Element 4 is there. Okay. Now run this and give some element which is not there. For example, if I give 0 here, 0 is not there, right? 0 is not found. If I give any other element, let's say 99 or something, or 15 or something, okay, which is not there. 15 is not found. Okay. Fine. So, hope guys you got the idea how to implement the linear search algorithm for finding the required element. So we can make this program more better. Instead of writing the code in a very simple format, use a scanner class to collect the target element from the user and search the target element either in the arrays or collections framework. Okay, anything you can search for. So in place of these arrays, you can also implement array list also if you want. Okay, if you want to implement array list, you can implement that, but some logic will change. Okay, here create one more method, public static int linear search demo2, I'll say demo2. And here instead of array, right, I'll collect the array list. Okay, so I'll say array list integer control Z, sorry, array list integer. Here I'll say al comma int target element. Okay, here integer also you can give if you want. Okay, int or integer, whatever it is, target element you find. And here hover the mouse on the array list and import it from java.util package. Hover the mouse on this. Return statement should be there. Return type I mentioned, right? Just put it white for now. And what is the logic? For example, here in this program, we have the array list also. Yeah, let's assume that this is a place I will write the code for the array list. I'll create an array list here. Array list integer. You can, this is one part of the program where I have explained with the help of arrays. And another part of the program where I'm trying to find in the, here I'll write system.out.println. The separation you can say. Assume that this separation. This you see, you can use this linear search algorithm to search for the element, in the arrays or in the array list. Okay, such kind of indexing related stuff. So here I'll write a list is equal to new array list of integer, and write down the circular brackets here, put a semicolon here, then a list dot add all. There's a method like add all method. Then you can say list dot of method. Here you give all the elements that you want to. Let's say 9. Same elements I'll provide this. I'll provide the same elements. Okay. Okay, array list dot add all of what is the method add all. The type array is not applicable to the arguments list, is not for the arguments of list scanner. Okay. Okay, I'm just giving a scanner. I just wanted to copy these array elements, guys. Okay, sorry. Okay, I'm giving the elements. Now, in the array list, we have all these elements added, guys. Instead of adding using add method separately, right? You can use add all method like this to add all the elements at a go. This element will be stored at the index 0, similar to arrays, guys, but it is an array list. It's a collection of objects, whereas this is a collection of primitive values. Okay. Now the same for each loop you can write. The logic will be same, guys. The same logic will be there. Logic will be same. Write down the same logic here. But here instead of array, we'll get the array list. Here array list we have to write. Here length method will not be there for collections. So size method will be there. Give the size method. Here write down al of I is equal to, okay, t al of I. Here al of I is not possible. We have to say al dot get of I, I have to say. Okay. Here array of I. Okay. Index will be like this. In collections, we have al dot get of I is equal to t. Then return I. Otherwise return the index. Otherwise return -1. Okay. Here again integer or int type you can say, no problem. Okay. The task is done using this simple modifications you have to do. You want to make it work, and you have to call this method, guys. You have to call this method. I'm also searching for the same target in the arrays and array lists. It's the same target I'll take. Again, if you want to take another target, again, you have to use the scanner thing here. Okay. So here linear search demo method demo2, right? Demo2. Okay. Put a semicolon here and pass here array list as one of the argument, and another one pass that as a target, same target. Target you pass. This particular target that you have collected from the user, you pass it. Go to the integer, and it will be upcasted automatically. Don't worry. Over the mouse, int result 2. Result 2 is result 1. This is result 2. So here write down if that result 2 is not equal to -1, then write down the code system.out.println. Target element is found at the index result 2. Else you will write down target element is not found. Simple. You don't have to print the index of the array list here. Okay. Simply print out this. Now run the code and see what is happening. Two methods I created here. One of the example for arrays and another example. You can give any of this, if I give 8 here, for example, 8 is found at the index 4, 8 is found at the, I'll change the order in which the elements are stored in the array list, guys. So I'll pick this element somewhere. Okay, Control Z. I'll just take this element somewhere here instead of giving them here, right? Comma 9, comma. Like this, I'll give some numbers. Okay. Now let's see what will happen. Different values will get. Index will be coming different. If I write 8 here, 8 element in the array is found at the index 4. 8 element is found at the index 0 in the array. For example, 9 I'll try to find. Try to find the 9. 9 in the array is found at the index 0. Yes, in the arrays, it's the 9 is at the index 0. Whereas 9 in the array list at the index 5. Let's find it out. 0, 1, 2, 3, 4, 5. Okay, like that. If I give some number that is not available in both the things, okay, let's say give some 11. 11 element is not found. 11 element is not found. Okay, so like this, guys, you can implement this linear search algorithm. Okay, there's a linear search algorithm. I think I'm not able to make it more. Lot of lines of code is there, so I think it's not possible for you to copy this. Okay. So I'll do one thing. I'll just increase the font a bit. Yeah. Now you can take the screenshot of this main method in which, creating the array, collecting the input from the user and calling the methods to perform linear search. Okay. Till here, you can take a screenshot. Hope you have taken the screenshot. Now I'll scroll down here. Okay. Now take the screenshot of other methods, reusable methods I created, which are actually containing the logic for performing the linear search. This is a linear search for performing the linear search on the elements in the array. This is performing the linear search on the elements in the array list. Okay, like the two examples I have given here. So hope that you have taken the screenshot of this one also. Screenshot of the above one and screenshot of the below one, guys. Okay, hope you have taken the screenshots. So with this, I have successfully demonstrated how to write a Java program to perform linear search of a particular element in the arrays or list or collections, whatever you call. So that's all for this session, guys. Thank you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to demonstrate binary search. Let me answer this question with practical demonstration. Before I directly go to the practical demonstration of this implementation of binary search using Java program, you need to first understand what exactly binary search is. As the name says, search means you are searching for a particular element in a list of elements. Okay, in a collection of elements, you are trying to find the element. Okay, so that's what is binaries. That's what is search means. But there are different type of searching algorithms. Guys, binary search is one of the algorithm we have that we can implement in Java to find the required element in the list of elements. Okay, we need to find some element in the list of elements. Other searching algorithms we have are linear search. We have, okay, we can also call the linear search as sequential search. And apart from the linear or sequential, we also have hash search. Like there are many type of algorithms are there, guys. But there is one type of algorithm like binary search, using which we have to find the element. It can find the element faster. Okay, when you have very good number of, okay, very big list of elements are there in that, if you want to find the element quickly, if you go with the linear search kind of mechanism that I have answered in this previous question, in previous interview question of this series, okay, if you go to the previous question and answer, I explained about linear search where it will go sequential manner. Linear search will go in a sequential manner where it will check first element, then if it is not matching, then second element, then third element, fourth element, like that, end of the elements. But in binary search, it's not like that, guys. Okay, we'll be able to quickly find the elements in a big list of elements, big collection of elements. You cannot use linear search for big collection of elements. So in that case, we'll go with the binary search to make the searching of that particular element in the collection of elements, big list of collection elements faster. Okay, so that's what is binary search. So binary search is a powerful searching algorithm in Java programming that you can implement in Java to find the position of the target value within the sorted array. You see, in order to apply the binary search, we need to have the array as a sorted array, guys. Okay, we have to sort the array. Okay, in order to find the position of a target element. Okay, here whatever the array you are searching, it should be in sorted state. Okay, if it is not in sorted state, that is in ascending order kind of state, it should be there. Okay, the lowest number or element should be in the beginning indexes, and the highest value should go to the as proceeding indexes. Okay, so like that, small number to the bigger number, the collection should be sorted. Okay, so I mean array should be, collection of elements should be started in the array. Sorted array only we can apply the binary search. Normal arrays we cannot apply. Okay, this is very important, guys. Okay, so here, guys, if I take an example here, I'll try to give a lot of examples, guys, so that my intention is to explain you how to, how to work with this. For example, there are some elements here. If I give the elements like 9, then 5, then 7, then 1, then 4, then 2, then 6. Like this, if I give you the elements, are these elements in a sorted format? No. We cannot apply binary search in this case because you see, 1 should be in the beginning. Okay, sorted means 1 should be coming first, then 2 should come next after 1, then after 2, 4 should come, then 5 should come, then 6 should come, then 7 should come, then 9 should come. Okay, this is not an sorted array. On this kind of arrays, binary search is not possible. Binary search algorithm, we cannot search for the required element in this non-sorted array. For example, if I give you another array containing list of elements or collection of elements like this, for example, like if I give something like 1, 2, 4, 5, 9, 8, 9, okay, 9, 12, 14, 15. If I give the elements like this, they are in sorted order. This is a sorted array. These elements are in a sorted format because least element is in the beginning index and bigger number is at the last index. Okay. And in, you see 1, 2, 4, you see ascending order kind of elements are there. This is called as sorted array, guys. For example, this kind of elements are stored into the array in this order. It's called as sorted array. So binary search will only work on the top of, binary search only works on the top of the sorted array, guys. It will not be working on the non-sorted array. Okay, here binary search is not possible. Okay, here only linear search is possible where one by one element you have to say, that will take time. But here coming to the binary search, it will work only on the sorted arrays. If it is not a sorted array, you will not get the result. First thing is that one. Okay, you have to understand that one. It works by repeatedly dividing the search intervals in half, hence reducing the number of elements to be checked. Why it is fast? Because the kind of mechanism is very simple, guys. You see, whatever the element you are searching for example, if you are searching for an element like, I'll take one element, guys. If you are searching for an element like 14, let's say 14 is the element you are searching in the sorted array. Let's assume, okay, target element is 14. Now, to find the 14, right, first it will get the index of here. Okay, left index, L is equal to 0. Index of the first element is 0. Index of the last element is what? The right index. That is 0, 1, 2, 3, 4, 5, 6, 7, 8. Here 8. Okay, L is 0, R is 8. So there is a formula, guys. Okay, so to get the middle element, okay, to get the middle element, there is a formula. What is the formula? The formula is L plus R minus L. Left index plus right index minus left index divided by 2. This is what is the formula, guys. Okay, to get the middle index, middle index of the middle element, this is the formula, guys. Okay, why this formula? You can say middle is equal to left plus right divided by 2. But there is a problem, guys. If the elements are, if these elements, there are big list of elements, there's a possibility that the index of this element and index of this element will be in higher sizes, and when you combine them, that will go in the out of range of the int value. For example, if you are using int data type, the range of the int will be there, right? If this right and left both are integers and if they are in bigger size, that what will happen? The integer will get overflowed. Okay, it will go over the integer and you'll get kind of compiler errors. That is the reason, instead of directly dividing the number by 2, instead of following this kind of formula, they are using this kind of formula where they are doing some minus here and then they are adding. Okay, instead of dividing them first, after adding and dividing, instead of doing that, they're adding later by doing this approach. That means R minus L. R is 8. 8 minus 0 is how much? 8. 8 plus 8 divided by 2. That will become 4. 4 plus L is 0. 4 plus 0 is 4. Index 4. Middle index is 4. 0, 1, 2, 3, 4. 8 is the middle element in that case. Is 14 target element matching with 8? Is the 14 target element matching with 8? Not matching. Then what it will do? Then they will do another thing. That is, if that is not happening, okay, this formula you understood, right? Right minus left, why they are doing? So if they use right plus left divided by 2, right, that may overflow the number. There is a possibility that overflow may happen. So they are subtracting, then adding. Okay. So by doing this subtraction, dividing by 2 and then adding to the left element, right, you will get the middle element somehow. Okay. So right minus left will give you the divided by 2. If you say right minus left, for example, here right minus left is how much? 8 minus 0 divided by 2, 4. 4 is the middle element or not? 0, 1, 2, 3, 4. 4 is the middle element, right? So it almost take you through the half of the distance of this numbers. So that's why they are using right minus left divided by 2. And they are adding to the left because they have to add to the left again. Okay, the division of this thing, they have to add to the left. So finally, adding this half distance to the left gives you the index of the middle element. That's why the result of this right minus left divided by 2, they are adding to the left case. Okay. So fine. Then finally, adding this half distance left will give the middle element index. Overall, this expression ensures that middle index is calculated correctly and safely within the current search interval. So what happened? What is the middle index we got finally? 4 is the middle index we got. So 8 is not matching with the target element. We'll try to retrieve this with the help of index the element. 8 is not equal to 14. So this is not matching. Then what they will do is, in the next thing, if that particular target is greater than mid element, for example, here target 14 is greater than 8, right? 14 is greater than 8. So in that case, what they will do is they will ignore the left part. So ultimately 14 is greater than 8 means it will be in this area. It will not be this area. So this area will be ignored. Okay. It will be in this area. So for that, left is equal to initially left was 0, right? Now they will make left is equal to mid plus 1. What was mid? 4 plus 1. That is 5. 0, 1, 2, 3, 4, 5. Okay. So what will be the left here? Left will become mid plus 1. What is mid? Mid was 4. 4 plus 1 is 5. So 0, 1, 2, 3, 4, 5. From here, 5. It starts from here, guys. Okay. Fifth index. till the 8th index, last index. In between 5 and 8, the element can be there. That's how they are, making the searching faster. You see, they have ignored all this stuff. These elements are ignored now. These elements are ignored now. The element is not there. Already we compared the middle element, that is not required. Less than middle elements also it will not be there because this particular element is less than the target. That's why they have ignored this part completely. Only they will focus on this part now. So they will make left is equal to mid plus 1 to right is equal to last index. That is the 8. Okay, 5, 8. Left is 5, right is 8. Now again they will apply the formula R minus L. What is R minus L? R is 8. 8 minus L is 5. What is that? 8 minus 5 is how much? 3. 8 minus 5 is 3 divided by 2. You will get 1. 1 as the index. 1 plus left. What is left? Left is 5. 1 plus 5 is how much? 6. The result will be 6, guys. Middle index will come as 6 this time. 0, 1, 2, 3, 4, 5, 6. This is the middle element now. Now they will compare this 12 with 14. Are they matching? Not matching. And here this target 14 is greater than 12. Again the same thing, guys. Again the same thing. Whatever the mid we got is 6. 6 plus 1 will become 7. So they will start from 7, guys. That is here. 0, 1, 2, 3, 4, 5, 6, 7. 7th index and 8th index. Now 8 minus 7. This is left. This is right now. Okay. 7 is left. 8 is right. 8 minus 7 divided by 2. 8 minus 7 is how much? 1. 1 divided by 2 is how much? 0. So here 7. 0 plus 7 is 7. Left is 7, right? So left plus this result. That is 7 plus 0 will become 7. So now currently the middle index is coming as 7. So 0, 1, 2, 3, 4, 5, 6, 7. It will take 14. 14 will be compared with 14. They are matching. So we have found the element. Okay. Within these 3 searchings, we got the element, guys. Okay. We don't have to search from 1, 2, 4, 5, 8, 9, 14 like that. Okay. Simply we can search like this. Okay. So there may be another example where, if the element is on the left side of the page, for example, here, we'll take some elements, guys. 1, 3, 5, 7, 9, 11, 12, 14, 15, 19, 21, 23, 24, 25, 27, 28, 32. Some numbers I gave, guys. Okay. What element I want to find is I want to find 3 here. I want to find the element 3. Let's assume that the target element is 3. In this case, here we have the left index as 0. Right index as what we have to find? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16 is the right index. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Okay. Now what we'll do is in order to compare this, find this particular 3, right? We have to get the middle index. To get the middle index, you know the formula, right? Right minus left divided by 2. And this one we have to add with left. Okay. So we'll get the R. R is 16. 16 minus 0 is 16. 16 divided by 2 is 8. So finally here we got 8. 8 plus 0 is 8 only. Here 8 we are getting. So 8 is the middle index now. 0, 1, 2, 3, 4, 5, 6, 7, 8, 15. Now 15, is it matching? Is 3 matching with 15? No. And the target element is less than the middle element. Target element is less than the middle element. So in that case, if the target element is less than the middle element, then we have to make right is equal to mid minus 1. What is right here? Right is equal to 16. 16 now will become mid minus 1 means mid is this one. Mid is what? 8, right? Mid is 8. 8 minus 1 will become 7. So 7 means this one. It will become 7 here. Okay. And here left will be 0 only. Left will be 0 only. That means we are simply ignoring this portion. This entire thing we are striking it off in a single go. You see, then there is no need to search element because the element is less than, so it is not possible. Okay. The element will be between 1 and 14 only range. So now this time L is 0 and right is 7. So again the same formula, right minus left divided by 2 plus left. Okay, left plus or whatever you say. Right minus left is what? 7 minus 0. 7 minus 0 is 7. 7 divided by 2. 2 3 is 3 plus 0 is 3. We get the result as 3. Index as 3. Middle index is 3. 0, 1, 2, 3. Here it got middle index as this one. The 3 is not equal to 7. 3 is not equal to 7. So it will not find the element. So, but it will check whether 3 is less than 7. If 3 is less than 7, if the target is less than the middle element, middle index element, then we have to make right is equal to mid minus 1. What is mid here? What was mid here? 3 was the mid, right? 3 was the mid. Mid minus 1 will become what? This one. Okay. So here, right will become 2. Okay. 0 and 2. Now what will happen? Again, the formula will be calculated right minus left divided by 2 plus left. Right is what? Right is 2. 2 minus 0 is 2. Divided by 2 is 1. 1 plus 0 is 1. So index 1, it came to index 1. Middle index is 1, 0, 1, 3. This is a middle index now. Now we'll compare this target element with the middle index element if they are matching. So we have found the element. So after doing all this stuff also, if you are not able to find the element, you have to return minus 1, guys. Okay, at the end you have to return minus 1. This is the logic, guys. And also, if the element is not found, let's say whatever the element you are searching for is not found, how that will happen? Let's see. Okay, until when you have to keep on repeating this finding the middle element index and middle index element and then comparing with the target element. But there may be some situations where the element is not available in the list. Okay, there may be some situations where the element will not be there in the list, the array list or something, array elements. So let's say here 1 is there, then 2 is there, then 5 is there, then 8 is there, 9 is there. Okay, then 12 is there, then 13, then 15 is there. Let's assume that these are the elements. Okay, in this case, this is a 0, and here this is a 0, 1, 2, 3, 4, 5, 6, 7. 7. Okay, so this is left, this is right. Now I want to find something like, I want to find something like element 4, let's say. I want to find target element is 4. If 4 is available, no. But how the searching will happen, you see. First, it will say it will try to get the middle element, right minus left divided by 2 plus left, or left plus anything you can write. Right is what? 7. 7 minus 0 is 7. 7 divided by 2 is what? 2, 3 is the 3 plus 0 is how much? 3. Middle element is 3. 0, 1, 2, 3. Okay, it will take the middle element as 3. And here 8 is not equal to 4. So 4 is less than 8. If 4 is less than 8, what it will say? Then it will make the right as middle minus 1. Okay, it will ignore this part, complete this part it will ignore, and it will start searching only in this area from 1 to 5. Okay, 0 to middle minus 1, that is middle minus 1 is nothing but 2. Okay, 0 to 2. So 2 minus 0, right minus left divided by 2. That is 2 divided by 2 is 1. 1 plus 0 is 1 plus 0 is what? 1. So 1 is a middle index. 0, 1. It will take the middle index as this one. Okay, it will take the middle index as this one, that is 2. 2 is equal to, is 2 equal to 4? Not equal. Still not found. Then what it will do? Then what it will do, guys? Then it will check. Again, it will say middle minus 1. Okay, it will check middle minus 1. So right will be becoming, if the, here 4 is less than 2 or greater than 2, basically. 4 is less than 2 or greater than 2. 4 is greater than 2. 4 is greater than 2. So in that case, what will happen if target element is greater than the middle element, target, then ignore the left off. It will ignore the left off, guys. Okay, this part it will ignore. This part it will ignore. And it will say left is equal to mid plus 1. Left is equal to mid plus 1 means mid plus 1 is mid is 1. 1 plus 1 is 2. It will take this one as the left. 2 is L. Then right is equal to last index. Right is also equal to left. Both the same. Only one element is left, right? All this one got gone and this one part got gone. Only 5 is left. Now left and right are equal. Okay, left and right are equal. There is a condition, guys. If left is less than or equal to right, if left is less than or equal to right, then it's okay. Here left and right both are equal. The left and right are both are equal, guys. In that case, what will happen if the left and right are equal? Right minus left will become in 0. 0 divided by 2, 0 plus that is 2, right? That is nothing but 2, right? Left and right are both are same. So left is 2. So 2 will be the result. 0, 1, 2. It will take middle element as 5. It will compare 4 and 5. Are they equal? Are these 5 and 4 equal? Not equal. In that case, it will check 4 is greater than or less than 5. 4 is less than 5. Then it will do m minus 1. M minus 1. M minus 1 means what? 2 will become 1. And 2 will become 1. Okay. And earlier, right index is 2. Now, see here is left equal to, this is a, so just see here, if the 4 is less than 5, the target is less, what will happen? Right is equal to mid minus 1 and left is equal to 0 or the changed left. Okay, 0 or changed left, you have to say. Right is equal to mid minus 1. What is mid minus 1? Mid minus 1, I told you already. Mid was this one. Mid minus 1 is 1. Okay. Right is equal to 1. What about left? Left is equal to 0 or change left. Already left has been changed to 2 here. So now is left less than or equal to right? Left is what? 2. Is 2 less than or equal to right? No. In that case, we'll come out of the while loop phase. Okay. And we'll stop searching. And then we'll simply return if the left is not equal to right will happen. This condition is, if the left is not equal to right condition becomes false, right? Then we are going to return minus 1. Okay. That means the element is not found. So I'll programmatically explain again, guys. Don't worry. Theoretically, you're trying to understand because without theory, you cannot go to the program, and without program, you cannot understand some theory. Okay. So this is the thing, guys. Okay, this is the thing. So let's practically demonstrate this logic to find the element using binary search. So I'm going to write the code, guys. With this code, you should understand how the binary search should be implemented. It's very interesting, guys. If you take it as interesting, it is interesting. If you take this as difficult, it will become difficult. Okay. Class 7, some random number, click on finish, and we'll create a main method. Make sure that the array, I'll explain all the stuff, guys. Again, I'll explain all the stuff. Don't worry. With an example, I'll say public static void main is already there. I'll create an integer array, guys. AR is equal to, this array should be in sorted manner. Otherwise, binary search will not work. So give the elements like this 1, 3, 5, 7, 9, 12, 13, 14, 15, 16, 18, 19, 19, 20, 22, 23, 24, 25, 29. Okay, like that some elements I gave, guys, very big list I gave. This, now we need to get the, so this is array, guys. In this, we have to find a target element. That target element, I would like to collect input from the user, guys. New scanner class I'll write. I would like to collect this as an this number that I need to search in this array from the user. For that, I'm writing the scanner. Control-Shift-O, and here I have to write system.in. Okay, scanner will be imported from java.util package. And now simply write a message to the user to enter any number. Enter any number to search, to binary search or to search. Okay, this number is going to be the target element that you want to search in this array. Whatever the element that user enters, right, that we have to see whether that particular element is there in this array, sorted array or not. Okay, this should be a sorted array, guys. If it is not sorted array, you cannot work. I told you here already, it should be sorted array only to implement the binary search. Binary search will only work in the sorted arrays. Otherwise, it not work. Okay. Then next one is, we'll collect the input from the user. Next int of, int target. Int target. Target is equal to, okay, like that. Now, once you get the array and once you get the target element, it's better that you create a reusable method here to do that binary search. Public static void binary search demo. Okay, binary search demo. Some name I'm giving, some random name, and to this I'll collect the array here, that is ARR. Here only one R is there, double R. Just giving a different name. You can give the same name also. And here I'll say int T for target. Let's say. Okay, now what I'll do here is once you call this particular method, you are going to pass this particular array to this method, and you also ask to pass the element that need to be done searching. Okay, to be searched in this array elements. Okay, fine. This binary search demo method should return the index of that particular target element in this array, sorted array. Okay, fine. That's the plan. Now, what we have to do is, first we have to find the left index and right index. Okay, first we have to find the left index and right index. What is the left index? The first element's index is the left index, that is 0. So how to get the left index? Int left is equal to 0. You directly write 0. This is left index, guys. Now write int right is equal to, right means right index, guys. What is the right index? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is the right index. How to get that? Tomorrow, if the array changes, then how to get that? Okay, dynamically, if you want to get that, ARR, the array dot length you say. This will give you the last position of the, how many elements are there? Total 17 are there. Okay. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 are there. But I want to get the right index. The last element's index will be right minus 1, guys. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's not 17, it's 16. So that's why we have to write minus 1. ARR dot length minus 1. Once you do that, left is equal to 0, right is equal to ARR dot length minus 1. Then we have to create a while loop. The condition is very simple, guys. Okay. We have to search this particular target element in this array elements until one condition is not failed. That is, left should be less than or equal to right. Until left index is less than or equal to right index. Until the left index is less than or equal to the right index, till then you can iterate, guys. Till then you can iterate. Okay, otherwise you cannot iterate. Okay, till the left index is less than or equal to the right index, then only the iteration or searching operation should continue. Otherwise, simply you have to say return minus 1. Okay, if you are coming out of the while loop and no index has been written in this while loop, then you have to simply return minus 1, and here return type should be int. Okay, that means the element is not found. Now here in the while loop, when the left index is less than or equal to right index, we have to apply a formula to find the middle index. How to find the middle index? I already told you, right? Int middle. Okay, middle is equal to int middle is equal to, okay, int middle is equal to left plus, left is what? Currently left is 0, guys. Left plus, in circular brackets you have to write right minus left divided. Theoretically I explained all this stuff to you already. Divided by 2. Okay, this is a formula we have to write. This is a middle index you will get. After getting the middle index, what you have to do is you have to compare if so how, what will happen here? Let's see. Right minus left is what? Right will become, here right is coming as 16, right? And the left is coming as 0. Already left is 0. 0, 16. 16 minus 0 is how much? 16. 16 divided by 2 is how much? 8. 8 plus 0 is how much? 8. So middle is nothing but 8 now. Okay. Middle is nothing but 8. If this array, whatever the array that is passed, ARR of I, or ARR of, ARR of middle, okay, this middle index is equal to the target element that you are passing, whatever the input you have collected from the user, right? You can write scanf.close here at best practice. Whatever the input you got into the target from the user, right? That target element you are passing here, and just putting the T here. If it is equal, then simply say return middle as the index. Okay, this middle is nothing but the index where that particular target element is available in this sorted array. Okay, else you don't have to do anything, guys. Okay, else so if that is not there, then else block, if this is not matching, then we have to do something like this. What is that something? We have to compare. If that is not equal, then we have to compare whether the target element is either greater than this middle element or less than the middle element. If the target element is greater than, okay, the target element, if this particular target element value, that is what is the target element for the user has given some target element, if that is greater than this array of middle index, okay, in that case, if this not equal and target element is greater than the array of middle index, means that means target is on the right side, it's not on the left part, right? Okay, so target, maybe this portion will take and this portion will ignore, like that, guys. Okay, this portion will take. Okay, if target is greater than, what we are writing, target is greater than this middle element means. So we are dividing this sorted array into two parts. This part will not be there because the element is greater than this middle element. So after the middle element, we'll compare here. Okay. So this part. So for that, we'll write target is like that. Then have the formulas already here, guys. If the target is greater than middle element, ignore the left halves and make the left is equal to mid plus 1. Make the left is equal to, new left will be, earlier left was 0, right? Now left is equal to this middle plus 1. What was the middle actually? 8. 8 plus 1 will become how much? Left will become 9 then. Okay. Left is equal to middle plus 1 and right will be same only. Right will be same only. Else if this particular target, anyhow target is not equal to middle, in that case only the else block will come. In the else block you write right is equal to middle minus 1 you have to say. Okay. If that particular target element, what is happening guys? Middle plus 1, I'm getting an error. What is it? It's semicolon I missed. Okay, that's the reason. Okay. So if that particular target element is not greater than, but it's less than, okay, the target element is less than middle element, then you have to say, if any change left will be there, that will be the updated left will be there, and right will be, new right will be mid minus 1, that is middle minus 1. So if that is like 8 means 8 minus 1, it will become 7 in that case. Okay, 0. Okay, left will be 0 and right will be 7. In between 0 and 7, it will if that particular target is less means less than middle element means it will ignore this one. This will take this part. Okay, like that. Okay, like that we have to write the logic, guys. Okay, until we find that. So now let's run the code and observe that what is happening step by step. Okay, so let's run this code. Okay. Let me run this code. Right click run as. Let's say the user has entered something like 3. The user has entered the number to be searched as 3. So here what will happen if the user enters 3? For example, once you call this particular binary search demo, if the element is found using this binary search algorithm, this binary search is going to return you the middle index. That index will come here in the result index. Okay, result is nothing but the result index. Here I'll write down if result is not equal to -1, then I'll write system.out.println target element is found at index. Which index? This result index plus result I'll write plus result. Else I'll write system.out.println target element is not found. Okay, it's not found. Okay, -1 means it's not equal to -1 I have, right? If it is -1 means it's not found. Definitely, if you are returning -1 means after all this while loop iterations, the element is not found in this list. Okay, now run the code again. Right click run as Java application, and here you give a number like 3. 3 is found at the index 1 is coming, guys. That's correct only, right? 3 is there in the index 1 only. How that is happening? When the user enters 3, target will become 3. Okay, this target will become 3, and array is already there. Here T is nothing but here T is how much? 3. Target element is 3. Array is this array, whatever the array. Okay, whatever the array, that is array. I'll do one thing. I'll just take a screenshot of this code so that I can show you. Okay. So target element is 3 and the array is this particular array, guys. Okay. In that, left will become 0. Left will become 0. That means here, I'll try to draw something here. Left will become 0. 0 is nothing but this one, guys. Okay, or I have to write using a pencil better. 0. Okay, left will become 0. And what is right? What is right in this program? Right will become ARR dot length -1. That is 16. 16 is the right. Here 16th index. Last element index is 16 is the right. Okay. Now, while left is less than or equal to right. Left is 0, right is 16. 0 is less than 16. Condition is false. We'll come inside that. Now we are calculating the middle like this. Middle is equal to left plus right minus left divided by 2. Right is what? Right is 16. 16 minus Left is how much? Left is 0. 16 minus 0 is how much? 16. 16 divided by 2 is how much? 2. 8 is 16. 8. 8 plus left is how much? 0. 8 plus 0 is 8. So middle will become 8 here. Okay, the middle has become 8. ARR of middle means at the index 8, guys. Okay, at the index 8, whatever the element is there here. Here what came, guys? Just go here. Middle index has come as 8 means just see here 0, 1, 2, 3, 4, 5, 6, 7, 8. Here is a middle element having the index as 8. This 15 will be compared with, now in the next logic, what will happen? AR of middle is equal to T. T is 3. Is AR of middle is, AR of 8 is how much, guys? AR of 8 is 15. 15 equal to 3? No. We'll go to the else block. And here if it will compare whether T. T is nothing but what? 3. 3 is greater than 15. 3 is greater than 15? No, it's not greater than. So it will skip this one. It go to the else block. That means if T is less than 15, if T is less than 3 is less than 15, that is correct. In that case, right will become middle minus 1. What is middle? Middle is 8. 8 minus 1 is how much? 7. Right will become 7 now. Once the right becomes 7, where is the 7? This is the 7. Okay. This will be ignored now, guys. It can clearly understand the element is not there here. It will understand. Okay. This will not be searched anymore. This part will not be. Now, left has become this one and right has this one, this one. Okay. This is left. This is right. Now, again, it will check the while loop. The searching will continue where, left is less than or equal to right. What is the left now? Left is still 0 only. Then what is right now? Right is 7. 0 less than or equal to 8. Correct? Sorry, 7. 0 less than 7 is correct. So again, we'll go inside that middle is equal to 0 plus, otherwise, 7 minus 0. That is 7 divided by 2 is how much? 2 3 is 6. 3 will come. 3 plus 0 will become 3. It will become 3. Middle will become 3. Now 3 is nothing but 0, 1, 2, 3, 7. This element 7, guys. Okay. This will become 3. Index 3. Okay. Index 3, 7. So that middle element, array of middle element is nothing but 7 here. 7 is equal to 3? No. Again, no. It will go to the else block. If that 7 is greater than, if that target element 3 is greater than 3, sorry, target element 3 is greater than 7, 3 greater than 7, no, 3 is not, else block. Right is equal to middle minus 1. What is the current value of middle? 3. 3 minus 1 is how much? 2. Now the middle element will become 2 here, 0, 1, 2. So this will become the, this 2 will become the, right index. 2 will, index 2 will become the right index, and this all will not be searched anymore. This part will not be searched anymore. Okay, this is gone already. Then 0 and 2 are there. Now again it will go here. While left is how much now? Left is still 0. Right is 2. 0 less than 2 is 2. We'll go inside that. Middle is equal to left. Left is how much? Left is 0. Right minus left is how much? 2 minus 0 is 2. 2 by divided by 2 is 1. 1 plus 0 is 1. So middle index will become 1 now. So middle index has become 1. ARR of 1. ARR of 1 is how much? ARR of 1 is 3. ARR of 1 is 3. So 3 equal to 3. 3 equal to 3 is true. This time it will return the middle. The method execution will stop and it will return the middle index, that is index 1 will be returned here. If that 1 is not equal to, so here binary search method will store one index 1 into the result, and that 1 is not equal to minus 1. So then it will go to the if block and say target element. What is the target? 3. 3 element is found at the index 1. Correct only, right? That's how it is working. Okay. That's how it is working, guys. Okay. That's how we got the result like this. This is how the binary search algorithm will work. 3 element is found at the index. Now, what if I give another index number? Let's say if I gave you something like 23. When I press 23, it will say 23 element is found at the index 13. But how you are getting this particular result? How the binary search algorithm is able to find that this 23 is available at the index 13 here in the sorted array? For that, you are entering what? 23 element you are entering. Okay. Target element is 23. Array elements are there. Left is equal to 0, right is equal to 16. That's okay. Length of the array minus 1 is the right index. Okay. Left 0th index is the first element's index. 0 less than 16 less true will go inside the middle is equal to right minus left. Right is how much? Right is 16 minus left is how much? 0. 16 minus 0 is equal to 16 divided by 2 is 8. 8 plus 0 will become 8. 8 will be the index. Middle index is 8. AR of middle is 8 means what? 0, 1, 2, 3, 4, 5, 6, 7, 8. 15. 15 is the 8. And here we have 16. We have 16 here, guys. Okay, we have 16 here. Okay, here 15 is there. So AR of middle is how much? AR of middle is 15. Is 15 equal to 23? Is 15 equal to 23? No. It go to the else block and now check. It will check target element 23 is greater than 15. Correct only, right? 23 is greater than 15. Then it will say left is equal to middle plus 1. Initially left was 0, right? Now left is becoming middle plus 1. That means middle is this one, 8. 8 plus 1 is 9. This is left now and this is right now. Earlier left was 0 here. That means this part, no more searching will happen. Here no more searching will happen here, guys. Okay. Now left is 9, right is 16. In that case, it will go here. Left is what? 9. Right is how much? 16. Left less than or equal to 16. True or false? Yes, it is true. Go inside that. 16 minus 9 is how much? 16 minus 9 is 7. 7 divided by 2. 2 3s are 3. Left is how much? Currently left is how much? 9. Right? Left is 9. So 9 plus 3, 12. Take the middle index as 12. AR of 12 is how much? 9, 10, 11, 12. 12 is this one. This is the 12, guys. This is 12. This is 12. Okay. 12 is 22. This is a middle element now. Okay. AR of 12 is nothing but 22. 22 is equal to 23. No. Again, else block. 23 is greater than 22. Correct. Again, left will become middle plus 1. Left will not be 12 anymore, 9 anymore. Okay, it will be middle plus 1. That is, left will become 13. Left will become 13. That is 23. This is left. This is 13. Okay, left will become 13 now. Okay, because of that. Left is equal to middle plus 1. Middle is, earlier middle was 12. 12 plus 1 is 13. 13 will become the left. That means it is no more going to search here. This part. This part is gone already. Now, next thing is, it will search from left and right. Okay, so left is 13 and right is 16. So here it will go 13 is less than 16. Still true. 16 minus 13 is 3. 3 divided by 2 is 2 ones are 1. 1 plus here 1 will be there. 1 left was what? What is the left? Left is 13. 13 plus 1 is 14. We'll go to the 14. Middle element AR of 14 is how much? AR of 14 is 24, right? 24. AR of 14 is 24. So 14 will be the middle index. 14 will be the middle index. Okay. AR of 14 is 24. 24 equal to 23? No. Else block. Is 23 greater than 24? No. Else right is equal to, right will become, left will not change. Left will be 9 only, but right will become middle minus 1. Okay. Current middle is what? 14. 14 minus 1 is how much? 13. In 13 and 9, it has to search. Okay. 1 minute. Something I have done a mistake here. Okay. Right, it has changed, right? So there is something that I have kept. Just let me go back here. Okay, this has done this one. And now in 9 and 16, what happened? 16 minus 9, that is 7. 7 divided by 2 is 3. 16 minus 9, right? 3 plus 9 is 12. It will become 12. Middle will become, AR of 12 will become, what is AR of 12? 9, 10, 11, 12. This one, 23 is the middle element. Okay, this is 12. So 22 is 23 is greater than 22. So left will become middle plus 1. Here I didn't update, guys. Okay, that's the problem. 12 plus 1 means this will become 13 now. Left will become 13. In that case, 13 less than or equal to 16 still true. 16 minus 13. 16 minus 13 is 3. 3 divided by 2 is 1. Okay. 13 plus 1 is 14. It will become 14. Error of 14 is how much? Error of 14 is 9, 10, 11, 12, 13, 14, 24. Is 23 equal to 24? No. You go here and is 23 greater than 24? Sorry, is 23 greater than 24? False. Else block. Right will become, left is 13, right will become middle minus 1. 14 minus 1 is 13. So here left is 13, right is also 13. Okay. In this case, it will go to the left. 13 less than or equal to 13 is true. So 13 minus 13 is 0. 0 divided by 2 is 0. 0 plus 13. It will become 13 index. Middle error of 13 is what? Error of 13 is this 23 now. This 23 is equal to 23 true. Then middle index, that index 13 will be returned here. And 13 is not equal to minus 1. So here target element, that is 23 element is found at the index 13 will be printed in the output. This is how the result came. Got it, guys? Clear? Now, what if I give an element that is not there in this thing? I'll try to give an element which is not there in this. Okay. So I'll remove all this stuff. It will confuse you otherwise. Freshly, I'll give a particular number which is not there. In that case, else block element is not found should come. Let's run this code and try to give an element which is not there. Let's say I'll give something like 17 here. 17. 17 element is not found directly coming. How means 17 will go into this target. Here 17 will be the target, guys. Left is equal to 0, right is equal to 16. Right is equal to 16. 0 less than 16. True. 16 minus 0 is 16. 16 divided by 2 is 8. 8 plus 0 is 8. So index, middle index is 8. AR of 8 is how much? AR of 8 is how much, guys? 0, 1, 2, 3, 4, 5, 6, 7, 8. This one, guys, 15 is nothing but 8. So 15 equal to 17? No, false. 15 is not equal to 17. 15 is not equal to 17. So else block it will go and see whether the target element is 17 is greater than 15. Correct. 17 is greater than 15. 17 is this particular 17 target element is greater than 15. So it will go here and say left is equal to middle plus 1. Okay. Earlier left was 0. Earlier left was 0. Now left is equal to 17. This middle was what? 8. Left is equal to middle plus 1. That is 8 plus 1. That is here 9. 8 plus 1 is nothing but 9 here. Okay. 16. This is left. New left is this one. New left is 16 here. Okay. That is 9 and 16 index. Okay. Here till 16 is there. Index 16 is there. So now it will go and see left. Left is nothing but what? 9. 9 less than or equal to 16. 9 less than or equal to 16. This is 16, guys. 9 less than or equal to 16. True. 16 minus 9. 16 minus 9 is how much? 7. 7 divided by 2 is how much? 3. 3 plus left is 9. 3 plus is 12. Middle will become 12. AR of 12 is equal to how much? 9, 10, 11, 12, 22. It will become 22. Okay. AR of 12 will become 22. That is 22 equal to 17. False. Else block. Is 17 greater than 22? False. 17 is less than 22. So right will become middle minus 1. Earlier left has become what? Left has become 9, right? Here left has become 9. Now right is becoming what? Middle minus 1. That is middle is how much? 12. 12 minus 1 is how much? 11. Okay, right will become 11. Middle minus 1. Right will become this 11, guys. Okay. 12 minus 1, that is 11. Okay. This is left now. This is right now. Okay. This is left and this is right. Right to right. It's not clear, but that's okay. Right is equal to 9. Okay. Now again, left less than or equal to 9 less than or equal to 11 is 2. Then come here. 11 minus 9 is 2. 2 divided by 2 is 1. 1 plus left is 9. That will become 10. Middle will become 10. AR of 10 is how much? 9, 10. That is 19. Okay. This is the element. Okay. 19. Is 19 equal to 17? No. Else block. Is this 17 greater than 19? Now middle has become 11, right? Okay, this one 10 actually, 10, sorry, not 11, 10. This 19 is nothing but 10th index. So in this case, what will happen? That is 19. 17 is greater than 19. Greater than air of 10 means this one only, right? Is 17 greater than 19? No. Else block right will become middle -1. Current middle is 10. It will become 9, guys. Okay, it will become 9. Left is 9, right is 9. 9 is less than or equal to 9 is true again. 9 minus 9 is 0. 0 divided by 2 is 0. 0 plus 9 is 9. Here middle will become 9. Air of 9 is how much? Air of 9 is the 16. So 16 equal to 17 false again, else block. Then T will become what? 17 is greater than 16. 17 is greater than 16 false, else block. Then right will become middle -1. That is 9 minus 1, 8. Then it will compare here. Left less than or equal to right. Left is what? 9. Is 9 less than 8? No. Is 9 equal to 8? No. Finally, we will coming out of the while loop and return -1. It will return -1 saying that result will be -1. -1 not equal to -1 is no. -1 not equal to, this will return -1, right? -1 not equal to -1 will become false. We'll go to the else block and it will print target element. That is target element is what did we give here? 17, right? 17 is not found, will be printed in the output. 17 element is not found, will be printed. This is how the binary search algorithm in detail I covered, guys. I don't know whether you can take the screenshot. I think you can take the screenshot. It's okay. You can take the screenshot, guys, and try and bit increase the size here and see if you can take the screenshot. Okay, somewhat is missing. Some spaces I have to remove. Otherwise, I'll try here and see. Yeah, can get this thing. That's fine. Okay. Now we can take the screenshot of this code, guys, for binary search algorithm. Okay. So hope, guys, I tried my level best in explaining you what exactly is a binary search algorithm and how it works with finding the element in the sorted array. Everything I covered with the formulas and all. What is the need of the formulas, how the formulas, and how it is going to find the element. Okay. Why it is fastest when compared to the linear search or a sequential search, which is the simplest search we have. But binary search is not simplest search. We have to go with this algorithm. Okay. This kind of logic we have to write to find the element in the list of elements. Okay. So hope you have taken the screenshot. So with practical demonstration, I've answered this question for you with all the theoretical and practical explanation. I covered this answer for you in a detailed manner. So that's all for this session. Thank you. Bye-bye.